Right, so we're doing part C now, and this is where the fun and games really begins, because what we tried before when we had probability x is greater than or equal to 1 isn't going to work any longer, and I'll tell you why. Let's have a look at the question. So it says we've got to find the smallest number, so we've got to find out what n is equal to, and we need to ensure the probability of more than 0.95 of hitting the bullseye at least twice. So here we want probability x is greater than or equal to 2, and we want that to be greater than 0.95. So we kind of start the same way we started before, but let's keep going. So remember, another way of writing this is going to be 1 minus probability, let's put this in brackets, x equals 0, plus probability x equals 1 is greater than 0.95. And we do the same thing we did before, so we take the 1 across there, and we've got minus outside of PR x equals 0 plus PR x equals 1, and we want that to be greater than negative 0.05. Now we divide both sides by the negative, and that means we've got probability x equals 0 plus probability x equals 1, and that's going to be less than 0.05. Okay, let's have a look and see what happens next. Remember, n was unknown. So if we're writing this out by hand, we're going to write this as NC0 like we did before. Our probability of success was 0.2, so it was 0.2 raised to the 0. Probability of failure was 0.8 raised to the n. Remember, we don't know what that's equal to. Plus NC1 times 0.2 to the 1 times 0.8 to the, now what's that going to be? N minus 1, isn't it? And that has to be less than 0.05. Well, there's some good news here. That's still equal to 1. That's still equal to 1. So it's 0.8 to the n plus NC1 is actually equal to n. 0.2 to the 1 is 0.2. 0.8 to the n minus 1. Well, that's just 0.8 to the n minus 1. And that's less than 0.05. So the problem I wanted to show you was if we now put this into a calculator, and I've already pre-done this, we're trying to solve 0.8 to the x. Remember, I'm putting in x plus x times 0.2 to the x plus 0.8 times, plus 0.8 to the x minus 1 is less than 0.5. Let's press x in, let's see what happens. Well, basically nothing is what happens, and so we need to find a better way of doing this, and that's basically what we're going to try and do now. So let's pause for a minute, and I'll get it ready for the next section. Okay, so what we've seen is that this doesn't work on our calculator, so there has to be another way of doing it, and it turns out there is. But what we're actually going to do is we're going to rewind back to that opening line there, where we had probability x is greater than or equal to 2 is greater than 0.95. We're going to input this into our graph. We're going to put y1 is equal to something. Now, this time, because we've got greater than or equal to, that means we're going to use binomial CDF. So we're going to put this in binomial CDF. Now the calculator would want to know what the lowest value is. Well, the lowest value is 2. It also wants to know the highest value. The thing is, that's what we don't know because we don't know how many trials there are. So we're going to put an X in. Similar story for the number of trials. That must be the same number. And our probability of success was 0.2. So we're going to now put this into our Y1 screen. Let's bring the calculator up and get that happening. And, oh, what a remarkable coincidence, it's already there. And so there it is. So it's got binomial CDF 2x(x).2. Now remember, we want to know when this is greater than 0.95. So on our table, which remember, if we're here, we get the table from there. If we scroll down, we'll notice when x equals 7, the probability was 0.2 or 4233. No. Too small. We want it to be bigger than 0.95. Oh no, even when it's 14, it's not bigger than 0.95. Oh no, 17. Oh, this is going to keep on going forever. Now you might remember last time we actually stopped at 20. I've actually been back inside and I've changed it to an upper number of 30. That means I can keep going here, but if you had forgotten how to do that, we just go up here and we can change. In fact, I'll change it to 40. I've gone really crazy. So let's keep going, and we're looking for the first time when it becomes bigger than 0.95, and there it is, 22. So now we can write, therefore, n equals 22, and that is the word. Okay, bye for now.